When you design an optical system, such as an automotive illumination device, headlight, taillight, signal lamp, it's not only important and necessary that you meet all of the regulations, the standards, whether they be European or Japanese or Asian or the American standards in terms of performance, but also there's a need to have the appearance of the illuminating device have a particular look and feel. There are two important criteria. One is the unlit appearance. What does the actual illuminator look like? The other is what's called lit appearance. What does it look like to someone who's seeing this illumination system as it's being used? Here's a simple case of a reflector designed here at Breault. And here's the basic system. We have a clear lens in the front. We have a source that's actually offset below. And we have a reflector that's actually made up of hexagonal facets placed on a curved surface. And what we want to do is not only see what this looks like as a physical object, but what does it look like as the source is illuminated and it reflects off the reflector and through the lens. And here's some graphical information. All of this is taken directly from ASAP files, where we look at what the image looks like or what the light looks like as you view it from a series of angles of incidence. Other things you might want to do include things like taking into account the environment that the system that's being illuminated will perform under. And although this is slightly different type of system, what we're looking here, for instance, is the shadows and reflections off the tire of a sports car. And if you notice, the shadows move as the wheel moves. All of these need the simulations of surface scatter, as can be done in ASAP using BSDF models.